Greetings. I've already gone over the introduction to Module 5 briefly, and I'm starting my video lecture series on Module 5 and going over the PowerPoint with you guys. And here's the first one. As it was mentioned, the concept here is point and interval estimation. Our target parameters for one population are mu. So we'll be estimating the mean, the percentage, the standard deviation, and the variance. And we also will be estimating the difference between the two means and the difference between two proportions. Just in general, in order to estimate a confidence interval or to estimate the mean of a population, single population, we'll be using we're going to obviously be using formulas to do all of this. And in the formulas for mu, we're going to use the z values that you've seen before. For p, we're going to use z values. For sigma, we're going to use chi-square values, which you haven't seen. It's another distribution, just like the z. Well, not like the z, but from a statistical point of view, it's just different. It's a skewed distribution. And I'll give you commands that you could use to find it. And for sigma squared, we also use chi-square distribution. Now, sometimes for mu here, we'll be using what's called a t-distribution if population standard deviation isn't given. So for mu, we'll use both of these values, and I'll give you guys commands on Excel as to how to find them. The z, the t, the chi-square, these are all different continuous distributions. In our class, we only learned the normal distribution because the t and the chi-square are a bit more advanced. So we're not going to bother with those. We're just going to teach you guys commands as to how to find them. For mu1 minus mu2, also we're going to use z and t values. And for p1 minus p2, we're going to use z values. So moving on, and as I explained earlier, the concept here is estimation. So in general, we're trying to find these variables, statistical variables, or estimate them. But we can't do it because it costs too much or it takes too long. So we find the best point estimate for these. So the best point estimate for mu is x bar, like the best approximation for it. The best approximation for sigma is s. The best approximation for sigma squared is s squared. And the best approximation for p is p hat. So these are called sample variables. Now remember that population variables are called parameters. Sample variables are called estimates or statistics. So remember, these are called parameters, these are called statistics or estimates. I've given you formulas on how to find these, but we're not going to use formulas, we're just going to use commands. So if you want to find the average, you're not going to add and divide by n, you're just going to type average. We're not going to use this, we're just going to type STDEV. We're not going to use this, we're just going to type variance. And to find p hat, you just divide x by n. So that's how you'll find these sample variables, and these sample variables is what you have to use to estimate the actual population variables. So you're going to use x bar to estimate mu. You're going to use s to estimate sigma. You're going to use s squared to estimate sigma squared. You're going to use p hat to estimate p. You're going to use p1 hat minus p2 hat to estimate p1 minus p2. You're going to use x1 bar minus x2 bar to estimate mu1 minus mu2. You'll see all of these in formulas, but what I'm trying to show you is that you always use the sample information to estimate the actual population information. And that's what's going to happen. You'll see in the formulas that in order to calculate mu or estimate mu, they use x bar. Moving on, I've shown you the concept here when I was introducing you the concept of Module 5, is that if you want to compare, let's say, the averages of two populations, mu1 and mu2, and you want to know if they're equal, if there's a difference or whatever, you find a confidence interval for their difference. That's how you estimate them. But since you can't have any information about the actual population, what you notice is you take a sample and you find sample information, and based on this sample information, you'll be able to estimate what the difference of two population means are. And that's the basic concept of this chapter. I've already written we already gone over the 8 items that we need to do in this chapter on the intro. I'll mention it again. These are literally the 8 things you need to do in this chapter. Basically, if I would give you questions from this chapter, it'll be one of these 8 questions. You'll be asked to construct the confidence interval for the mean when sigma is known, for the difference of the means when sigma are known, for the mean when sigma is unknown, for the difference of the means when sigmas are unknown, for the population proportion, for the difference of proportion, for the population standard deviation, and for the population variance. So there are 8 things we're going to be doing in this chapter. We're going to be estimating mu1 minus mu2 in different formats, p1 minus p2, sigma, and sigma squared. So these are the things we're going to be estimating. And I'm going to start with the first one here. So the first one is constructing a confidence interval for the population mean. So basically estimating the mean when sigma is known. Here's the formula I would use for that. And again, these formulas you need not memorize because you could use them all during the exams. So here's the formula you constructed the confidence interval for the mean. That's the mean. So basically you need to calculate the left-hand side, which is known as the lower confidence limit. Lower confidence limit, they call it. Sometimes they call it the left-hand side. And this side here, they call this the upper confidence limit, or the right-hand side. So basically, to estimate mu, you want to figure out what the left-hand side is and what the right-hand side is. And that would be your final answer. So your final answer would be something like mu is between 100 and 107. So this is a final answer. And that's what it looks like, and that's what you want to get. So you start with this formula. You'll be given these parameters here. You'll be given these values. And you probably calculate this yourself based on the accuracy level indicated. And that's it. Once you have these values, you can just plug them in, and then you get some kind of a number. And that's it. That'll be the end of the problem. All right. Now for the z-value, I've given you a command here, but there's an easier command I want you guys to use instead of this. This will work too, but I want you guys to use the one we used previously. So what I want you guys to type is, if you want to find the z-score for a given confidence level, which is the accuracy measurement for all of these problems, and you always will be given it. By the way, the accuracies are going to be like 90%, 95%, 98%, pretty accurate, 99%. These are the common so-called accuracy levels. They're known as confidence levels. We talked about this a while ago as I was foreshadowing that the area of the belly of the normal distribution, remember that area there, if that's given like 95%, we call that the confidence level. I gave you guys a lecture on this a long time ago. I was foreshadowing it because it was coming up now. So the belly is called the confidence level, and the area on the outside, we'll sidetrack here, the area on the outside here in the tails. So like if the middle is 95%, then both of these tails are 5%. We call that the significance level. And we also call it alpha, if you recall. We're going to use this in the next chapter. In this chapter, we're going to be focusing on the belly, which presents the accuracy level for your estimation. So now one way to do it would be to just memorize these values. Like for 90%, it'll be 1.645. For 95%, 1.645. For 95%, it'll be 1.96. 2.33 if you round it to 2 decimal places, and for 99 is 2.576. So these are the values. You can just memorize them. They'll never be any different, but I'll nevertheless show you how to calculate them anyways. So let me erase the stuff here. You guys could always rewind and watch what I wrote. So I'll have room to write other things. So we know what we're trying to find. We know what's going to be given and what we're going to find. So let me just drive through an example. Okay, so So if I'm estimating the mean and sigma is given, this is the formula I would use. And for the command, I would use equals norm.s.inverse, always inverse in this chapter. And instead of 1 minus the confidence level, divide by 2. I'll do it the way we've been doing it before. Take your confidence level. Let's say I'm just going to go with like 90%. Divided by 2. So, and do it with decimal. So 0.9 divided by 2. So you get 0.45. And you do this on Excel or a calculator. And then take that value and add a half to it always. Add a half to it. And this half always remains the same. It never changes. So you add a half to 0.45. And you get 0.95. And that's what you use in here. And it will give you the right value. Okay, so let's drive through these examples, see how you use this particular example. There's 8 different examples in this chapter, and I'm going to do each one of them with you. Here's the first one. So we're doing a confidence interval for a mean of the population when sigma is given. So I have a problem here. The U.S. Department of Health, Education, and Welfare collected sample data for 1,525 women. The sample had a mean of 191.7 and the population standard deviation was 41. It says use a 98% confidence level, there's the accuracy, to find a confidence interval for mu. So at this point, you remember you have 8 different formulas that you have to choose from. So you need to read the exercise and realize, oh, okay, this is the one that says construct the confidence interval for the mean. So it's a single mean, one population here. You have 2 formulas for that. If you notice on your formula sheet, and you need to decide which one you're going to use for this exercise. Well, they're both finding a confidence interval for the mean, so they both could be used for this because it's asking you to find a confidence interval for the mean. But which one do I use? Well, it really has to do with this thing here, the standard deviation. Because here you have the population standard deviation. Here you have a sample standard deviation. So which one do we use and when? Well, if it's the population, you notice this population standard deviation. If the population standard deviation is given, so obviously we're going to go with this formula. If the population standard deviation, if it didn't say population, it just said standard deviation, then we would use this formula because then we're using just the plain sample standard deviation. So that's how you could tell for the mean which one to use. All right. So again, let me clean this up. All right. So we're going to use, so we know what formula to use here. So my formula is going to be, and I'll just write it, x bar minus z sigma over square root of n, x bar plus z sigma over square root of n. That's the formula. Now let's see. Now I write the information. Now what's my n here? It's 1,525. My sample mean, which is x bar, is 191.7. A lot of students by mistake write this as mu. And I just want you to realize that doesn't make sense, because if you knew what mu is, then why would you bother doing all this to begin with? So obviously that's not mu. If I know mu, then why would I need to estimate it? So any information that's given about the mean in the exercise, it has to be the sample mean. Because if you knew the actual mean, then you wouldn't even do this problem. Why would you? Because you already know. If you know something, why would you need to estimate it? So therefore, any information is given to you about the average here is x bar, not mu. Mu is what you're actually trying to estimate. You don't know what mu is. So the whole idea in this problem is you don't know what it is, so therefore I want to estimate it using the formulas that have been given in this chapter. Okay? So your mu is not given. You need to find it. So it's x bar that's given to you. Now it says population standard deviation. So sigma is 41. And my confidence level is 98%. Now I have everything here except, it's like they've given me everything except the z-value. Now how am I going to find the z-value? Well, remember, you either memorize it for 98% is like 2.33 or 2.326, whatever, how many decimal places you've been instructed to use during the test. But what if you don't remember that? Well, you just simply use the Excel command, which is you take 98, you divide it by 2, you add a half to it, and then you do the norm.s inverse of that. Okay, so it's 98%. I'm actually going to show you how to do this on a spreadsheet here. So one time you could see it. I've done it on my Excel videos, but I'll show you again here. Remember, the confidence level is 98%, and we're trying to find a z-value for it. So let me go to Excel. 98%. So the first thing I'll do is I'll say 0.98 divided by 2. That's what you do first. So half it. And then add 0.5 to it. So 0.5 plus, that's a 0.5 plus that value, 0.99. So that's the one I use in my dist formula. So let's see. So I can show you guys here. So I'll say equals to norm dot s dot inverse probability, and my probability is 0.99. There you go, 2.326, as I told you. So you either would have memorized it or you could actually compute it. I'll do it one more time. You take 98%, which is the confidence level, divided by 2, and then you add a half to it. And then you use it in the norm.s inverse formula. And you get 2.326 or 2.33, depending on how many decimal places I'm asking you to use. So let's say we use 3 decimal places here. I get 2.326. 2.326. So I get 2.326. So my z-score will be 2.326. Sorry. And you see, you have everything you need now to plug in. So this becomes 191.7 minus 2.326 times sigma, which is 41, divided by square root of 1,525. And that's, again, same thing on the other side with a minus with a plus in between. So you get 41 square root of 1,525. And that's it, guys. It's that simple. You just figure, I mean, it's basic. If you think about it, all you have to do is just plug in numbers in this chapter. There's not much going on here. You just have to learn how to find 3 things: the z, the t, and the chi-square. I've already shown you how to find the z-value using a command. And on the future slides, I'll show you how to find the t and the chi-square when we get to it. So here's the first example for estimating the mean when population standard deviation is given. I'll show you the computations, because that's all it is after here. You just have to grind this out, and you're going to get a number out of here and a number out of there. And I show it to you as I've done it here on my PowerPoint. The next page tells you exactly what I just did, plugs in the numbers and grinds them out, and that's what you get. So basically, you may never know what the exact average cholesterol level is for all women in the United States between the ages of 18 to 24. There's millions of them. But based on only 1,500 of them, you can estimate using a 98% accuracy that it's somewhere between 189 and 194. And that's the gift of statistics to the research world. You save so much money by going after 1,500 people instead of going after 300 million people. So it just saves a lot of money and time for companies and research institutions. All right, so moving on, the next one, I'll do another one. The next one is 100 randomly selected college students, GPA 3.15, average GPA, population standard deviation is 0.2. They want us to do a 99% confidence level. Using a 99% confidence level, they want us to estimate the mean. So again, they're asking me to estimate the mean. Population standard deviation has been given, so I'll be using the same formula I used in the previous example. So it'll be minus z times sigma over square root of n. This will be z x plus z times sigma over square root of n. My n is 100, it's given. My x bar, remember, any mean given to you is not mu, it has to be x bar. Population standard deviation, which is sigma, is 0.2. And my confidence level is 99%, which gives me a z-value of 2.576, but you don't need to memorize it, you could just figure it out. So again, we half 99, add 0.5 to it, and then we use it in the Z formula. I'll do that with you guys one last time so you could see it for the Z value. So we're trying to find the Z score for a 99% confidence level. So 99%, so let's say equals 0.99 divided by 2, and then I add 0.5 to it plus itself, 0.995. So here, instead of 0.99, you'll type 0.995, and that would give you the Z score for the 99%. And as I said, it's 2.576 if you round it to 3 decimal places, 2.576. Okay, so don't forget, divide the given confidence level by half, add 0.5 to it, and plug it into the formula. 2.576. So my Z-score is 2.576. And again, all you do is at this point is just plug things in. That's it. It's really a child's play at this point. So 3.15 minus 2.576 times my sigma, which is 0.2 divided by square root of 100, less than mu, and then same thing on the other side, plus 2.576 times 0.2 divided by square root of 100. And again, it just boils down to you guys multiplying all this out on a calculator or Excel and writing the number on the left side and the number on the right side. And just a reminder, in case you've been away from arithmetic for a while, when you're doing this, remember you first have to, you can't just subtract this 2 and then multiply it by 0.2 because you're violating the order of operations. Remember, multiplication goes first and then it's subtraction. So in reality, if you're doing this, like if you're doing this on Excel, then you just write from left to right. You don't have to worry about any of this. That's why Excel is so nice. But if you're doing this on a calculator, you can't start from 3.15. You first have to do this. You first have to take this number, multiply it to this number. So first, I'm going to use a red color here. So you multiply these two numbers together first, then you divide it by square root of 100. Once you figure out this portion here, then you subtract it from 3.15. In case you've seen what this area, this is called, this red circle, they call this the margin of error. I don't care much about names, but as long as you know how to compute it, but that's called margin of error. And you've seen the formula here, this formula here, they sometimes write it as x bar minus some error and x bar plus some error. They call that margin of error. And that margin of error is z sigma over square root of n. So this part here is called the margin of error, and they label it as E. Anyways, just vocabulary, that's all. So if you were to do this manually, guys, and Excel wasn't around, because with Excel it's easy, you just type what you see. It's really simple, but fine. So with Excel, you don't need to worry about any of this. You could just type it from left to right, but if you're actually doing it with a calculator, it's good for you to know and to realize that the order of operations is you have to do one more time this part first, and then add it to 3.15 or subtract it from 3.15. Now I've done this on the next page so you can see it. So you start with the formula, then you use the norm.s inverse of half of the confidence level plus 0.5. Always, 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 not any different. Then you use the appropriate number of decimal places that you've been instructed. Then you just plug them into the formula, and then use Excel. In here, I've actually literally shown you how to type it with Excel, and there's your final answer. So up to 3 decimal places. So here is how you calculate a confidence interval for a mean of the population when population standard deviation is provided. Thank you, and see you on the next video.